Okay, so we are going to talk about inequalities here. Um, we're going to do some graphing and some other things with these. We are going to specifically look at how to graph a linear inequality. We're also going to figure out how to shade correctly. And we're going to determine what is the solution set of an inequality. So first of all, a linear inequality looks like a line when you graph it, but how you do so is a little bit different, okay? So here we have an inequality. Notice that this is a less than or equal to sign instead of the equals that we would normally see. When you graph this, it's going to look like a line. However, there's also going to be some shading involved. So this is going to go a little bit farther than just simply graphing a line, okay? So when we're looking at an inequality, what the line, if you will, does is it separates the coordinate plane into two halves, each region, and one of them will be shaded. The line is considered the boundary of the region, and wherever the solution sets are contained is in the shaded portion. So for example, if I were to pick any point in this colored area, let's just say 4, 1, 4, 1 would be a solution of this inequality. So for example, if I plugged 1 in for y and 4 in for x, I would get 1 is less than or equal to 2 times 4 plus 1. Well, 1 is less than or equal to 9. That is definitely a true statement, which means that all of these points over in the non-shaded region are not solutions. So for example, if I take the point negative 5, 3, and I plug that in for x and y, I get 3 is less than or equal to 2 times negative 5 plus 1, which is 3 is less than or equal to negative 9. That is a false statement, okay? The other one was true because it was in the solution set. This one is false because this point at negative 5, 3 is not a solution of the inequality. So any point that occurs in that shaded region will make the statement true, and any point that's not in the shaded region will make it false. Now, there's also something to be considered with inequalities, and that's whether it's a solid or a dashed line. So when you see the symbol and it does not have the equals to under it, it graphs as a dashed line. When it does have the equals to under it, it graphs as a solid line, okay? So there's several different pieces we kind of have to look at here. Let's talk about how to do that. When we are graphing, we want to graph a related linear equation. So to go back to that other one, we would have just graphed y equals 2x plus 1. That would have been what we would graph to make the line. We would have to determine if it's solid or dashed. And then we want to pick a point that is not on the line. If you can, choose 0, 0 because it's the easiest. Plug it in and see if it makes the statement true or false. If the point you chose makes it true, then you shade in the region where that point is. If it's false, you shade in the other side. That's kind of a lot. Let's work through a couple and it should make more sense once we see it, okay? So we have this. First of all, I want to point out that this equation, 2x plus 3y is greater than 6, is an inequality in standard form. So to go back to our graphing, remember when something is in standard form, we graph it by finding the intercepts. So we plug in 0 for y and we solve for the x-intercept and we get 3. And then we put 0 in for x and we solve for the y-intercept and we get 2, which means that we have a point at x equals 3 or 3, 0, and at y equals 2 or 0, 2. Now, I'm ready to draw my line that is the boundary of my region. However, I need to decide if it's solid or dashed. I'm going to go back to this inequality sign, and I notice it does not have the equals to part. Therefore, it is dashed. So I'm going to draw a nice little dashed line here. I'm still going to include the arrows on the end because it's still a line. It's just a dashed one. And now I have to decide where to shade. I'm either going to shade in this area over here above the line or in this area over here below the line. I want to pick a point on one of the sides, it doesn't matter, to test and see if it's true or false. I like the point 0, 0. It's nice and easy. I can plug it in and I will very clearly know. So if it's true, I'm going to shade over here. And if it's false, I'm going to shade over here. So let's test the point 0, 0. So I'm going to plug in 0 for x and 0 for y and see if I get a number that is greater than 6. Well, I think you already know that 0 plus 0 is 0, which is not greater than 6. So this is a false statement, meaning I'm going to shade on the side that does not contain 0, 0, because 0, 0 is not part of the solution set, okay? So we graphed the line, we decided if it was solid or dashed, we picked a point, 0, 0, to test, we plugged it in, see if it's true or false, and then we shade. Let's try another one. So this inequality here, y is less than or equal to 3/5 x minus 2, is written in slope-intercept form, meaning I'm going to start with the y-intercept at -2, and then I'm going to follow the slope, which is up 3 and over 5, up 3 and over 5 from that point. So I'm going to go up 1, 2, 3 and over 5, 1, 2, 3, 4, 5 to the right. Now I've got some points here. I can make a line, but I need to decide if it's solid or dashed first. Well, that's where I go to the inequality, and it has the equals underneath. So I know that this is going to be a solid line. So I'm going to draw a solid line. Okay. Now I'm going to check the point to see which side I'm going to shade. And again, I like to use 0, 0. So this time, if it's true, I'll be shading kind of on top of the line. And if it's false, I'll be shading in this bottom corner area over here. So let's plug in 0 for y, 0 for x, and see what we get. So 3/5 times 0 is 0, minus 2 is -2. And so we get a statement 0 is less than or equal to -2. Well, we know that that's not right. That's a false statement. So I'm going to shade over here on the false side. There we go. All right, so here's one more. Let's look at this one. This one, again, is back to standard form. So I'm going to solve for my intercepts, which means I'm going to put 0 in for y to solve for x and 0 in for x to solve for y. So let's plug 0 in for y first. So I get 6x, is equal to, 3, which means that x is equal to 1/2. So I have my x-intercept at 1/2, 0. Then I'm going to put 0 in for x and solve for y, and I get y equals 3, which there's nothing to solve there. Y just equals 3. So I have a y-intercept at 0, 3. And my x-intercept is at 1/2, 0. So I'm going to connect those. I might actually go, let's see, this is down 1, 2, 3, and over 1/2. So I'm going to go down 1, 2, 3, and over 1/2 just to get another point. This is kind of a steep line. And I also need to decide if it's solid or dashed. So you look at the inequality sign, think about it for a second, and I'm hoping that you realized it's supposed to be dashed because there's no equals to. So we're going to make a dashed line. Now I want to check 0, 0 again, which means that if it's true, I'm going to shade on the side where 0, 0 is, which is to the left. If it's false, I'm going to shade on the side where 0, 0 is not, which is to the right. Let's put 0 in for x and 0 in for y. So I have 6 times 0 plus 0. We'll see if we get something less than 3. 0 is, in fact, less than 3, so this is true. So I'm going to shade on the true side. And there we go. That is linear inequalities. So hopefully you feel like you can graph an inequality, you can determine if it's solid or dashed, and you can shade correctly. Best of luck with your inequalities.